Hello, young chemists. Have you ever wondered why some metals jump into reactions like overexcited cricketers while others sit quietly like spectators in the pavilion? That mystery is captured in the electrochemical series, also called the activity series. It arranges metals by how easily they lose electrons and form ions. At the top are the eager ionizers like potassium and sodium, and at the bottom are the calm, composed fellows like copper, mercury, and silver. This simple ordering helps us predict which ions will actually get discharged during electrolysis. Think of it as the VIP seating arrangement of metals in the world of chemistry. At the very top, we find the restless ones potassium, calcium, sodium. These metals ionize most readily, meaning they lose electrons faster than you lose Wi Fi during a storm. For example, potassium loses an electron easily, written as K gives K plus 1 electron. But here's the twist, though they ionize easily, their ions, like K, are discharged at the cathode with great difficulty. So, in electrolysis, they prefer to stay dissolved rather than turning back into metal. Top of the chart, but stubborn in discharge. Now let's stroll down to the bottom of the chart where we meet copper, mercury, and silver. These are the introverts of chemistry. They don't like giving up electrons. Copper, for instance, becomes Cu2 plus by losing 2 electrons, but reluctantly. However, once they are ions, they get discharged at the cathode most easily. For example, Cu2 plus 2 electrons gives back copper metal. That's why in experiments we often see copper or silver plating out beautifully on electrodes. These are the elegant artists of the electrochemical stage. Here's where the series shows its true power. Cations, those positive ions, migrate to the cathode during electrolysis. But not all are equally eager to accept electrons. Sodium ions struggle to discharge, while copper and silver ions grab electrons like free pizza at a party. The lower you go in the series, the easier the discharge at the cathode. So, if you see both Na plus and Cu2 plus in the same solution, it's copper that will happily take electrons and deposit as metal. Always remember, position in the electrochemical series decides who wins the electron race. Now flip to the other side, the anions. These are the negatively charged ions, and like all negative vibes, they head straight for the anode. Once there, they lose electrons. But here's the twist, not all anions are equally eager to part with their electrons. Sulfate ions, written as SO4 cling tightly and are the least likely to give them up. On the other hand, hydroxide ions, written as OH-, are like impatient quitters, they give up their electrons very easily. That's why in many electrolysis reactions, instead of sulfate or nitrate getting discharged, it's the hydroxide ions that step forward. They lose electrons and form oxygen gas. The reaction goes like this. 4 OH- ions give 2 molecules of water, 1 molecule of O2 gas, and release 4 electrons. So, when in doubt, trust the electrochemical series. It's your cheat sheet to knowing which anion will bubble out first at the anode. Alright, let's test our prediction skills with an advanced example. Imagine we are electrolyzing aqueous copper sulfate, CuSO4, using platinum electrodes. The big question is, what products will we get? To figure this out, we use the electrochemical series. At the cathode, both copper ions, written as Cu2 and hydrogen ions, H are available. But copper sits lower in the series than hydrogen, which means it has a higher tendency to get reduced. So, copper 2 ions grab 2 electrons and settle down as copper metal. The equation is Cu2 aqueous plus 2 electrons gives Cu solid. That's a nice reddish brown deposit of copper. Now, swing over to the anode. Here we have sulfate ions written as SO42- and hydroxide ions OH-. Between the two, OH- is much easier to discharge. So hydroxide ions lose electrons, forming water and oxygen gas. The reaction is 4OH- aqueous gives O2 gas plus 2H2O liquid plus 4 electrons. So, our prediction is correct. Copper metal is deposited at the cathode and oxygen gas bubbles off at the anode. A classic case where the electrochemical series tells us who wins the race to discharge. So, to wrap it up neatly, the electrochemical series is a master list of metals and ions based on how easily they ionize and how readily they discharge. The higher ones like potassium and sodium ionize quickly but are poor at discharging. The lower ones like copper and silver ionize reluctantly but discharge very easily. Cations become easier to reduce as you go down, and anions become easier to oxidize as you go down. This series helps us predict electrolysis products, design refining processes, and even explain why certain metals are used in batteries. In short, it's the roadmap of electrode reactions. Remember, chemistry may look like magic, but with the electrochemical series, you're holding the magician's guidebook. Catch you in the next class where we'll dive even deeper into the wonders of electrolysis.